Hi students, welcome to Chemistry Online. So in previous class we discussed about filling of orbitals. Now we are going to discuss electronic configuration, and some electronic configuration of some atoms, electron configuration of some atoms we are going to discuss. In previous class we discussed about filling of orbitals in an atom. Now we are going to discuss electronic configuration of atoms. Okay, not all, some atoms we are going to discuss. See, first electronic configuration of some atoms. First of all, you know what is electronic configuration. What is electronic configuration? What is electronic configuration? Electronic configuration means distribution of electrons into the orbitals. Distribution of electrons into the orbitals is called electronic configuration. Distribution of electrons into the orbitals, okay, is called EC. Distribution of electrons into the orbitals is called EC. So notation of electronic configuration you have to know here. Notation, how electronic configuration can be denoted or noted means, so first one is nothing but S power A P power S power A P power B and D power C, this type of notation. This type of notation. A comma B comma C are electrons in S comma P comma D orbitals. Okay, A comma B comma C are electrons in S comma P comma D orbitals. That is one notation. Second one is nothing but orbital diagram. Orbital diagram. Orbital diagram. See, orbital diagram means in S subshell having only one orbital, in P subshell having 3 orbitals, and D subshell having 5 orbitals. Orbital diagram means S, P and D. S having only one orbital, P having 3 orbitals and D having 5 orbitals. Okay, so this is the way orbital diagram can be insisted. This is electronic configuration. Now we will write some electronic configurations. Now we will write some electronic configurations. Okay, electronic configuration of some atoms we will write. This is the way. Electronic configuration is nothing but a distribution of electrons into the orbitals is called EC. electronic configuration notation means S power A, P power B and D power C. A comma B comma C are electrons in S comma P comma D orbitals. Orbital diagram means S having S subshell having only one orbital, P subshell having 3 orbitals, Px, Py, Pz, and D subshell having 5 orbitals, Dxy, Dyz, Dzx, Dx square, y square, Dz square. Okay. Now electronic configuration of some atoms we have to write. Electronic configuration of some atoms. Electronic configuration of some atoms we have to write. See, first one, hydrogen. Atomic number is 1. Electronic configuration means here I am taking atom, atomic number, next EC electronic configuration and orbitals. Okay, this is the way. First atom is nothing but hydrogen. Atomic number is 1. Atomic number is 1. Electronic configuration is electronic configuration is 1s1. Next, orbitals means s orbital and p orbital, s comma 1s comma 2s comma p orbital. Orbitals, this is 1s, this is 2s, this is 2p. So here 1s orbital and 2s orbital and 2p orbital. Here hydrogen electronic configuration is 1s1, means only one electron in s orbital, remaining all are empty. Next, second one, helium. Atomic number is 2. Electronic configuration 1s2, means here s orbital how many? 2 electrons. One is upward direction, another one is a downward direction. Next, here 2s and 2p is empty. Next, helium, after that lithium. Atomic number 3. So electron configuration 1s2, 2s1. So 1s2 means in s orbital how many electrons? 2 electrons. In second s orbital how many electrons? 1 electron. And p are, so it is nothing but empty. Next, lithium, beryllium. Atomic number 4. Electronic configuration 1s2, 2s2. Then in s how many electrons? 2. In 2s how many electrons? 2. In 2p how many electrons? Empty. Next, beryllium. After that boron. Atomic number 5. Electronic configuration 1s2, 2s2, 2p1. 5, 1s2, 2s2, 2p1. Then s orbital how many? 2 electrons. Okay. Then p 2s orbital how many? 2 electrons. And p orbital how many? Single electron, 2p1. Then boron, after that carbon. Atomic number 6. Electronic configuration 1s2, 2s2, 2p2. Then s orbital how many? 2. And p orbital how many? 2. And 2s orbital how many? 2. And p orbital how many? 2. Okay, this is the way. This is the way. Next carbon, after that nitrogen 7, atomic number 1s2, 7, and electron configuration 1s2, 2s2, 2p, 3. And then how many electrons in s2? How many electrons in 2s2? How many electrons in p? Okay, 3. 1, 2, 3. This is nitrogen. Next oxygen 8, 1s2, 2s2, 2p, 4. In s how many? 1, 2. In 2s how many? 2. In 2p how many? 4. 1, 2, 3, and then pair. So first degenerated orbitals are filled with at least one electron, then pairing takes place. Next oxygen, after that fluorine 9, 1s2, 2s2, 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 2p5. So here increasing 1, 2, 3, 4, 5. Then how many? 1, 2. 2s how many? 1, 2. And 1, 2, 3, 4, and 5. This is the way we may write atom, atomic number, electron configuration, and orbitals which are present in the corresponding. So I wrote up to 9. Remaining you have to write up to 20 atomic numbers. This electronic configuration you have to complete up to 20 atomic numbers. Up to you have to, and so on. Calcium 20 you have to write, and calcium up to 20 atomic numbers you have to write the electronic configuration. Okay, write. Okay, write EC. EC means electronic configuration. This is the way electronic configuration can be discussed. Next, you have to know. Next, you have to know some anomalous electron configuration of some atoms. Anomalous electronic configuration of some atoms. Okay, anomalous electronic configuration. Anomalous electronic configuration of chromium and copper. Chromium and copper. Here, why chromium and copper possess anomalous electron configuration means for getting stability. See here, chromium, atomic number 24, electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d4. It is its electronic configuration. 10, 10 plus 10, 20, 20 plus 4. So here in s orbital how many electrons? 2. In d orbital how many? 1, 2, and see 1, 2, 3, and 4. It is not stable. It is not stable. For getting stability, it is not stable. For getting stability, its electron configuration, it is valence shell electron configuration. It can be changes 4s 1, 2, 3d 5. So it is a single electron in s, and here 1, 2, 3, 4. 1, 2, 3, 4, 5. So 3d5. It is a stable. it is a stable. So for getting stability, its electronic configuration changes from 4s2 3d4 to 4s1 3d5. So it is nothing but a anomalous electronic configuration. In the same way, copper. So what is the atomic number of copper means? So what is the atomic number of copper? Copper means 29. Electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d9. 4s2, 3d9 means in S how many electrons? 2, which is a stable. In D how many electrons? 1, 2, 3, 4 and 5. Then pairing 6, 7, 8, 8 and 9. Now it is not a stable. It is not stable. So its electron configuration can be changes to 4s1, 3d10. Then s orbital having how many? 1 electron. Then d orbital having how many? 10 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it is a more stable. It is a more stable. So already I told you in yesterday's class, in previous class, half filled orbitals or full filled orbitals are more stable than partially filled orbitals. So here partially filled, it is a half filled or a full filled. It is partially filled, it is half filled. Okay, so for getting stability, some atoms changes their electronic configuration. As a normal electronic configuration is nothing but a anomalous electronic configuration of so for example chromium and copper. Okay, next you have to know what is a nodal plane. What is a nodal plane? You have to know. Then here you have to know what is a nodal plane, how many nodal planes are in 2p orbitals and 3d orbitals, like that we are going to discuss. The topic nodal plane. What is a nodal plane means? The plane which can pass through the nucleus. On the plane, the probability of finding electron is 0. Is called nodal plane. Okay, plane have a chance to pass it through the nucleus. On the plane, probability of finding electron is 0. It is called nodal plane. So the plane which can pass through the nucleus, where the probability of finding electron is 0. So the plane which can pass through the nucleus and the probability of finding electron is 0, and the probability of finding electron is 0 on the plane is 0 on the plane is called nodal plane. Okay. For example, n is equal to 2, so L is equal to 1 for 2p orbital. N is equal to 2, L is equal to 1, so for 2p orbital. Hence, so nodal planes, L value is 1 means, so nodal planes is 1 for 2p. Then n is equal to 3, L is equal to 2 for 3d orbital. Okay, so nodal planes is 2. So this is the way. The L value is nothing but a nodal planes present in the corresponding orbital. For s orbital, L value is 0, means no nodal planes. I will show the nodal plane. For example, here if you take px orbital, so what is the shape of p orbital? Dumbbell. Here I am taking, it is a x, it is a z, it is a y, it is a y. So for px orbital, p orbital shape is a dumbbell. Dumbbell means so it having two lobes. It is the nucleus. It having two lobes either side of the nucleus, like this. Like this. So here probability of finding electron is a maximum. Next, electrons is a 0. Now here it is a nodal plane which can pass through the nucleus. Okay, it is nothing but a nodal plane. So for px orbital, nodal plane equal to zy. For px orbital, nodal plane is equal to zy. It is the plane which can pass through the nucleus. On the plane, probability of finding electron is 0. On the plane, probability of finding electron is 0. So it is nothing but a nodal planes. So for s orbital, 0 nodal planes. For p orbital, 1 nodal plane. For d orbital, 2 nodal planes. For f orbital, 3 nodal planes, like this. Okay, this is the way. So nodal plane and remaining discussed. Then here you have to know orbitals and nodal planes. Orbitals and nodal planes. Okay. For s orbital 0, for p orbital 1, for d orbital 2, for f orbital 3. Okay, this is the way we may calculate nodal planes. Okay, then one problem we have to solve. The problem is given in textbook, so you have to copy from textbook. So problem 1.16, page number 23 in textbook. Okay, so what is the given problem means mass of a golf ball is given. mass is given. Mass equal to how much? 40 grams is given. Then speed is given. Speed equal to 45 meters per second. Accuracy is given. Accuracy is given 2%. Okay. Then delta x, uncertainty in the position we have to find. Delta x we have to find. It is a given problem. A golf ball mass 40 grams, its speed is 45 meter per second. Then accuracy in the speed, accuracy is 2%. In the speed, accuracy is, in the speed accuracy is 2%. Then we have to find delta x. See here, mass grams is given, that is I am converting into 40 into 10 power minus 3 kg. Okay, speed 45 meter per second. Then accuracy is 2%. So therefore speed, uncertainty in the speed is, therefore uncertainty in speed is equal to total speed how much? 45 into 2 by 100. Then 2 ones are 2 50s are. So 5 9s are 5 10s are. This is a 0.9 meter per second. 0.9 meter per second. So we know according to Heisenberg uncertainty principle. Heisenberg uncertainty principle. Delta x into delta v is equal to h by 4 pi m. Then we want delta x. Delta x is equal to h by 4 pi m delta x, m delta v. Then you have to substitute the values. Then you have to substitute these values in this equation. So delta x is equal to delta x is equal to h means 6.626 into 10 power minus 34 joules into second by 4 into pi means 3.14 into m means 40 into 10 power 3. 40 into 10 power minus 3 kg into delta v. Delta v means 0.9 meter per second. Now it is given in joules. So joules you have to convert it into kg. 1 joule equal to kg meter square second minus 2 I am writing in the place of joule. Then delta x is equal to 6.626 into 10 power minus 34. In the place of joule I am writing kg into meter square into second minus 2 into second. Okay, by 4 into 3.14 into 40 into 10 power minus 3. Okay, kg into 0.9 meter per second. Is my second minus 1 going up means second minus 2 cancel. Okay, this meter square cancel. Then kg cancelled. Then what is remaining? Equal to meter. Only meter is remaining. Then 10 power minus 3 going up means plus 3. Then 6.626 into 10 power minus 31 by 4 into 3.14. So 40 into 0.9, 36. Then if you simplify this, then you will get 1.46 into 10 power minus 33 meter. This is delta x. Uncertainty in the position. Delta x equal to uncertainty in the position of electron, in the position. Okay, so this is nothing but equal to delta x. Uncertainty in the position delta x. This is the way the problem is solved. It is very important problem. The problem is given in textbook page number 23. You have to copy that. So I written data. The golf ball has a mass 40 grams. It has a speed 45 meter per second, and it is a speed accuracy in the speed is 2%. Then we have to find uncertainty position. So is delta x. This is a solution. Okay, so this is briefly about atomic structure. Atomic structure chapter is finished, which carries 8 marks. In this chapter you have to read perfectly 3 long answers. What are they? Bohr's postulates explanation of hydrogen spectrum, then Bohr's theory, merits and demerits, quantum numbers. These 3 are important for IP. Remaining all are for objective type. Okay, this is for atomic structure, which carries 8 marks.